So now next let's talk about something called rethrowing exceptions. Uh, Basically, as you can see in this very short piece of sample code, we have a try block in which we have a block of statements, some or any of which may throw an exception. That exception is caught in the catch block, as we've seen before. And we handle that exception in the catch block. But something else that we can do is we can use a throw statement to throw the exception, to rethrow the exception, meaning it can be handled again at in some other place, usually from calling, can be handled again, usually in a method calling the method inside of which this code exists. And another thing, in addition to the catch block, another something else that can be added to exception handling is something called a finally block. And I'll show you how or when exactly the code inside the finally block executes. The finally block is so after a try block, we have one or more catch blocks for different exception types. And at the end of all catch blocks, we can have, don't necessarily have to, but we can have a finally block, which contains its own uh, block of statements. So let's say, let me show you how execution would proceed if, let's say, we have a try block and no exception. No exception is thrown by any of the statements in it. In that case, um, execution after the all the statements in the try block are completed, execution will continue in the finally block. So basically, the finally anything that you put in the finally block will execute uh, even if there's no exception. And of course, following that, execution continues after the finally block. Now, let's assume we have a number of statements in the try block, and one of the statements, let's say statement 2 over here, throws an exception. And that exception is caught in this catch block, and we handle that exception. Uh, and after the code in the catch block completes execution, we enter the finally block, and all statements in the finally block are executed. And when that is completed, execution continues with the statement following the finally block. Now here is another example. In this one, as you can see, we have a try block, we have a catch block, we have a second catch block, which is, as you can see, rethrowing the exception, and we have a finally block. So this is perhaps the most interesting case, uh, and I'll show you how execution will, what the sequence of execution of statements will be in this example. So let's say again, statement two throws an exception, and that exception matches the type exception 2. We enter the second catch block, we handle the exception, and the last statement over here is a rethrowing of the caught exception. But before this rethrowing of the exception occurs, we jump to the finally block, execute whatever's in there, and then jump back to the line that rethrows the exception in the second catch block. So this is perhaps a little unexpected, this jumping from the catch block to the finally block and then back to the catch block to rethrow the exception. What you have to remember is that exception handling is neat in a sense in that it separates the code that should or is expected to execute during normal program execution from all the code that we want to run when things go bad, when an exception is thrown. But that does not mean that you should use or be using try and catch blocks for uh, any place there's a chance of an exception occurring. Sometimes, for very simple cases, it's actually preferable that instead of writing your code like this, uh, where you are calling the toString method of an object, uh, uh, instead of doing it this way in a try catch block, is perfectly all right, of course, perfectly correct. Sometimes it's better to take the simpler route, especially when you have something like this where you can easily see that it's quite possible that a reference to an object may end up may end up being a null pointer, may not be pointing to anything. So in that case, it's sometimes simpler to just use an if-else statement. Now, another thing we can do is, um, as you remember, any class that you create yourself is automatically, unless you specify otherwise, is automatically a subclass of the Java API's object class. The object class being the superclass or grandfather class or parent class of all classes, the ancestor to all classes. Um, you can so in that sense, whenever you create a class, you are extending the classes that Java provides you. We can do the same thing for exceptions, which means we can create our own custom exceptions for use in our own projects, in our own code. So in the next example, we'll basically do that. We'll create a custom exception class, and we'll call it invalid radius exception. And we'll use that in a class called circle with radius exception, and we'll write a test program with a main method that creates objects of class circle with radius exception, which in turn is using this custom exception class invalid radius exception. So let me jump to the code here. So this is the exception. Let me walk you through that. So we're calling it invalid radius exception, and it extends the Java's exception class. Okay. It has a member variable called radius, and the idea is that this exception it's basically beyond this. It's really just like a lot like any other class in the sense that yes, it has a member variable and it has a constructor, and the constructor takes as an argument a radius, a double argument of that'll be the radius, and it also comes with its own accessor method, getRadius. As you can see, I'm going to use this in our circle with radius exception class. You can put other stuff in your custom exception class. So I'm going to we have this this class circle with radius exception. It has a member variable called radius and a static integer member variable, number of objects, which is going to track again the number of objects of this class that you are creating in your program. The noR default noR constructor just makes a call to another constructor that takes a radius as argument, which in turn, in a try block, attempts to assign the passed argument to the attempts to assign that value to the radius member variable up here using its set radius method, which is paired with a get radius method. So we have accessor methods over here, and if that succeeds, it proceeds to increment the number of objects member variable by 1. So let's take a look. So there's not much over here that can throw an exception. So let's take a look at the set radius method, and as you can see, inside of set radius, this is where we may or may not throw an exception, and the condition under which we the set radius method throws an exception. You can see that it says so here in this, where we're defining set radius method throws invalid radius exception. If the value of the radius that we're attempting to assign to the object's radius member variable, if that is greater than or equal to 0, everything's fine. But if we attempt to assign a negative radius to the circle, we go enter the else block and throw an invalid radius exception, and we pass to it the value of that radius we attempted to assign, which obviously will happen only when that value is negative. And obviously radius with circle with a negative radius measurement doesn't make much sense. And just to kind of round stuff out, we also added a find area method to this class. So let's jump to our test program. And in the main method, we have a try block, catch block, and a statement, print statement at the end, just to demonstrate that the code continues to execute after the catch block. We create a circle with radius exception object called C1, and this object C1, this circle object is assigned a radius of 5, which is fine, this will not throw an exception. But then what we do is we call the set radius method on the same object C1, and we attempt to assign it a negative radius. Now remember, when you call the set radius method and the value of the radius passed to it is negative, this will produce an exception. That's what we hope to see, because when the object was created, the radius at that time was a positive value, the object itself will succeed in creating that object, which means number of objects will have been incremented to 1. And after that, we have one more line in which we attempt to create a second object. Obviously, we won't get there because this line over here will throw an exception, which will take us to the catch block for this very specific invalid radius exception. Will print out EX, and after that we print out circle with radius exceptions number of objects. So let me run this. And we see what we see. As you can see, when we tried to assign a negative radius of -5, this threw an exception, and at the end we printed out the number of objects created, which, as expected, is 1 because we never get to uh, the creation of the second object, C3. We never get to that line in the try block. So before I finish this chapter, I want to talk about one more thing very quickly, concept called assertions. So an assertion is a Java statement that enables you to assert an assumption about your program. Uh, so jump ahead. Uh, Basically, uh, instead of using exception handling, exception handling is used uh, when there's actually a problem, an abnormality in the way your program is executing. That's when we use exceptions. If you just want to confirm along the way that your program is executing the way you expect, if that certain variables, for example, uh, have values within expected ranges, uh, is a better way to track that using assertions. Uh, Let me show you an example of that. Uh, Here, for example, is a very simple main method. Uh, we are declaring an integer I and another integer sum, initializing it to 0. And I is being used as a loop counter variable in a for loop, going from 0 to 9, uh, as long as it's less than 10, so ending at 9. And sum uh, is basically adding up the values of the for loop counter I, is adding the value in each iteration of the loop into sum. So at the end of that, we expect, after we come out of the for loop, we expect that the value of I will be equal to 10, as the condition uh, necessary to exit the for loop. And in addition to that, without um, we know that the sum will be larger than 10, and sum will be less than 5 times 10, 50, for example. And then you can, if that is not the case, you can print, we expect to see this string out here. Now, by default, uh, the use of assertions in Java is disabled. So what you have to do is you have to enable assertions, and you do that using the -EA switch from the command line. Now, we haven't been using the command line uh, for our programming assignments. We've been depending on NetBeans, on the NetBeans IDE. So here's the same program that we just saw, uh, repeated or imported into the NetBeans IDE. If you run this as is, you'll see nothing special over here. Um, so let me change the value over here from sum greater than 10, sure, and sum greater than 50. Now this is obviously going to be false, but if I run this, I still see nothing. It's because the use of these assert statements, these assertions, is currently still disabled. So if I want to make use of these, if I want to enable these, I first have to go into to change the project settings. And for that, go over here and see over here there's some VM, virtual machine options. You can just type in -EA over here, or if you're too lazy, you can go in here and select EA. Same thing, could have just typed it in, click OK, and let's run the first version. So this one, all assertions are satisfied. Now let me change the sign over here, so this assertion will not hold, or will be proven false. And there you go. Exception in thread main, sum is 45. So when this assertion proved to be false, we see this message over here, sorry, printed out to the screen. Sum is 45. So assertions are a great way to add in checks into programs that you're writing, common sense checks on the ranges, on the values that variables in your code are taking, and when there's a deviation from those assumptions, you can write yourself a very helpful error message like this. Now obviously, the more lines of code you put in, the more bloated your code becomes, but that's why you can so conveniently enable and disable the use of assertions. Once you have tested your code to your satisfaction and know everything is working the way you expect it to, you can simply go back into your project configuration and disable the use of assertions just like this, and you won't see and all of these assert statements are effectively removed from the program again. Yeah, so that's it about assertions, and at the end of the chapter on exception handling, and we'll move on to something new next week.